Okay, welcome to Monday. Go ahead and get out your homework. Let's grade this. All right, so we had 2 through 26 evens. Here we go. Questions 2 and 4 had an A and a B. So here we go. 2A is 4.5 and 2B is 0.045. Number 4, A is negative 0.6 and B is negative 0.06. All right, here we go. Number 6 is 0.916, and you put a line over the 6. Just the 6 repeats. Number 8, everything repeats. So it's 0.571428. Boy, that one didn't seem like it would be repeating, but it actually is. Everything repeats. Number 10, negative 0.46875. Number 12, 2.45, and the 4-5 repeats. Number 14, negative 6.75. And number 16 is 0.594. The 594 repeats. So put a bar over the 594. All right, number 18, 33 over 50. Number 20, 19 over 5. Number 22, 38 over 33. Number 24, 12 over 5. And the last one, number 26, negative 15 over 11. Okay, how'd you do? Count up how many you got wrong, put that in the Google Forms. You're going to notice today that there is no questions that I'm asking you on the Google Forms. Two reasons. Well, the main reason is that it involves square roots. It's not impossible to put a square root symbol into the Google Forms. It's just that it's a pain in the butt, and I don't want you to use a text form of writing SQRT to stand for square root, although you could. So we're just not going to do that today, and we're going to move on. So there's a quiz on Wednesday. The quiz on Wednesday will be 11-1, 11-2, and 11-3. So let's see. 11-1 was fractions. I'm going to give you two fractions and ask you what fraction is halfway between. Remember, you add up the two fractions, multiply by half. I'll ask you to compare the two fractions. Remember, multiply the means and extremes, and that tells you greater than or less than. I'll ask you last night's homework to convert something to a decimal or a fraction. And then lastly, what today's stuff is going to be on. Okay? Today is a really important class. All right, here's your homework for tonight. Okay, I just stated today is a really important class. There's many things that you learn in math. Today is one of those things. It doesn't seem that important, just seems like a regular lesson, but you will utilize what we learned today the rest of your math classes. Anytime you deal with a square root or a cube root or any root, you're going to be doing what I teach you today. It's really important. It's a little complicated, right? If you can wrap your head around it quickly, you're going to get this really simple. But some of you may need a lot of practice with this. It also is intuitive, meaning like you have to kind of get a good feel for what's going on. All right, there's two objectives. The first one is literally a reteaching of what I taught you last year in pre-algebra. It's the second one that's the new stuff. All right, so we're going to be doing square roots today, just square roots, not cube roots, but square roots. If you remember, and these are the same slides I used last year in pre-algebra. We started that lesson on square roots talking about these things called perfect squares. And if you don't recall, a perfect square is the square of an integer. An integer is the number, positive, negative, or zero, right? So if you take any number, not decimals or fractions, but any number, positive or negative or zero, and you square it. So for instance, 3, remember it's got to be an integer, and I square it, 3 squared is 9. That number 9 is what we call a perfect square. Okay? 4 squared is 16, so that number 16 is a perfect square. Now notice there's a whole bunch of numbers between 9 and 16. None of those numbers, 10, 11, 12, 13, 14, 15, are perfect squares. 9 is a perfect square. 16 is a perfect square. 10 is not a perfect square. 5 times 5 is not 10, it's 25. Notice there's a whole bunch of numbers between 16 and 25 that are not perfect squares. But 9, 16, 25 are perfect squares. Do you remember doing this slide last year? All right, you should remember this. I made you last year write down the first, technically this is the first 17 because I left off 0, the first 16 perfect squares. And we called this, I don't know, box 2 or something last year. I literally just taught this in the pre-algebra class. That's why I remember what box it was. But yeah, take a sheet of paper. You're going to need this. You're going to need this. Don't blow this off. Take a sheet of paper, write down the first 16 perfect squares. Now, technically, it's the first 17 because 0 times 0 is 0. 1 times 1 is 1, so 1 is a perfect square. Notice which one I'm calling, the answer is the perfect square. 2 isn't a perfect square, but 4 is a perfect square. 9 is a perfect square, 16, so forth and so on. All right, go ahead and finish that. Did you finish, or are you waiting for me to show you the answers? All right, 25 is perfect square, 36, 49, 64, 81, 100, 121, 144, 169, 196, 225, and 256 are perfect. They're not all the perfect squares, obviously, but those are primarily the perfect squares that you need to have memorized. This is going to have a multiplication flavor to it. In other words, you've got your multiplication tables memorized. You need to have these memorized. You'll see why here when I teach the class. So think about this. We have these inverses. The inverse of addition is subtraction. The inverse of multiplication is division. What's the inverse of squaring, right? Well, you know this from last year. The inverse of squaring is square rooting, right? It's what undoes the squaring process. Okay. Not to belabor the point, but this is how it's done. But what about this one? Well, if you remember last year, what I said was this is actually two operations. This is subtract the square root of 49. Well, by PEMDAS, which comes first, subtraction or square rooting? And you're like, well, I don't know. Well, remember way back when I told you that the square root symbol acts as a grouping symbol. Just like absolute value acts as a grouping symbol. So it's the P, the parentheses portion. That's why we call it GEMDAS, not PEMDAS. It acts as that first letter. So you need to take the square root of 49 first. Well, square root of 49 is 7 times 7. So that's the square root of 49 is 7. And then put a subtraction symbol in front of it. In other words, a minus sign. So when the minus sign is outside of the square root symbol, you do get an answer, negative 7. But if the minus sign is on the inside, we got big problems. Because what number times itself is negative 9? There is no number, at least not until we get to Algebra 2. So for right now, for this year and next year into geometry, there is no answer to this question right here. The square root of negative 9, if you type that into your calculator right now, yes, Jack, I know. As long as your calculator is not in the imaginary mode, it won't give you an answer. It'll say error. Right? Okay. You may not remember this one when you have the square root of a fraction. All right. You can break this up into the square root of the numerator over the square root of the denominator and do each one individually. Square root of 9 is 3. Square root of 25 is 5. So 3/5. So the square root of 1 over 100, we do the square root of the numerator over the square root of the denominator. We get 1 over 10. Am I going too fast? Okay, for those you need to rehear that, play that again. I did this a little quickly because, hey, this is exactly the same slides I showed you last year. All right, so real quickly, put it on pause. Just verbally to yourself, call out the answers, and then play and confirm your answers. All right, square root of 9 is 3. Negative square root of 100 is negative 10. Notice where that negative is. It's on the outside. Square root of 49 is 7. Square root of 16 over 225 is 4/15. How did I do that quickly? Because that box that I asked you to write the first 16 perfect square, 225 there, and 225 was there, and that was 15 times 15. Square root of 1 over 44 is 12. Square root of 1 over 25 would be 1/5. Negative square root of 16 would be negative 4, and the square root of 169 is 13. Trust me when I say the more of these you do, the easier it gets because you'll have these memorized. Okay. So there's a big but here, and We will get to the new stuff here. This is not the new stuff here, but it's just some comments about square roots. I know when I first learned about what I'm about to tell you, I didn't learn about this until Algebra 2. Our book chooses to show this to you right now, and it's okay. I'll show it to you. So think about this. The square root of 9, it asks the question, what times itself is 9? Well, that's 3, so 3 squared cancels each other. It's 3. There's one problem with this. There's another number multiplied by itself that's 9. Yeah, that's right. Negative 3 times negative 3 is 9. And you're like, wait, you said if negative was on the inside, there's no answer. Well, look what's going on the inside. I've got negative 3 times negative 3. Negative 3 times negative 3 is positive 9. There is no square root of negative 3, but if I do, because it's the order of operations, I do what's on the inside first, and I get a positive, I can get to an answer. So it turns out the square root of 9 is also negative 3. There's two answers here. The square root of 9 actually has two answers. We call the positive one the positive square root. Okay, the square root of 9 is 3. It is more precisely called the principal square root. Principal like in the principal of the school. The principal square root. And the other answer is called the negative square root. It doesn't have a fancy name. You put those two answers together, and the square root of 9 is technically plus or minus the square root of 9, because the answer is 3 and negative 3. Now, our book makes a point of this. This is literally like half of the page here that makes this point. And I'm going to go ahead, and I did it last year as well, too. I'm going to go ahead and teach this. I will just say we aren't going to use this year. We're going to only be looking at the principal square root this year. And next year in geometry, since distance is only a positive value, we don't have negative distance. When we take the square root of something, we only consider the positive answer. So even though, yes, the square root of 9 can be 3 or negative 3, we only consider the principal square root as the answer. But the notation there, plus or minus square root of 9, I know why they do this. Next chapter, which we won't get to this year, by the way, deals with the quadratic formula. And in the quadratic formula, you see this plus or minus square root symbol. And this is why they introduced this to you this year. So what's all this about? Let me quick give you an example. There's a couple of these tonight for homework. It'll say plus or minus the square root of 144. All they want you to do is take the square root of 144 and then attach a positive and negative to it. So yes, we understand that, yeah, potentially if you consider both possible answers, the square root of 144 is either a positive 12 or a negative 12. Plus or minus the square root of 1/9, yes. Technically the answer is either 1/3 or negative 1/3. And I'm going to close it right there. So this was your quick, down and dirty introduction to both answers to square roots. But I do want you to remember that for the rest of the year, like from this point onward, other than the homework, from this point onward, we're only going to be considering that the square root of 144 has one answer, the principal square root. And I'll just say most math books leave that out, right? They'll just say the square root of, last year we didn't even mention this, even though technically the square root of 144 has two possible answers. Does that make sense? Okay, don't get hung up on this. I'm also not even going to test you on this. This is just kind of an introduction. What I am going to test you on, though, is this new idea. Okay, here we go. So last year, we did take square roots of non-perfect squares, like the square root of 10, right? But we did the squeeze method. Remember we said the square root of 10 is somewhere between 3 and 4, closer to 3, maybe 3.1. We're not going to do that this year. And from your math onward, we're only going to consider ourselves with the exact answer. So 3.1 is technically a rounding of the square root of 10. We're not going to do any rounding. We're going to only have exact answers, meaning we're only going to use the equal symbol. Well, that's going to cause problems when we take square roots of non-perfect squares. Doesn't cause a problem when we do the square root of 9. Remember, from now on, we're only going to be considering the principal square root. So yes, technically plus or minus 3 is the answer, but we're just going to say the answer is 3. But when we do the square root of 12, we run into a problem, right? If we plug that into your calculator rounds this to an answer. I want an exact answer. I want to be able to put an equal symbol. We have one other technique that we can do. Right? This is called simplifying radicals. Radicals meaning the square root symbol. Okay? So how do you simplify this? You're like, well, I don't even know what to do. Well, one thing you can do is you can take that 12 and you can do some math with it. For instance, 12 is 6 times 2, right? Well, instead of using 6 times 2, all right, I'm going to consider another way of writing 12, 4 times 3. Why did I choose 4 times 3 rather than 6 times 2? Well, I want you to go back, if we were in class, this would have been done in box 1. I want you to go back to that list of perfect squares. And here's what you will do when you simplify square roots that are not perfect squares. You're going to ask yourself, is there any perfect square that I can divide 12 by and get a nice even number? Well, I can divide 12 by 4. 4 is a perfect square. Remember, the perfect squares are 1, 4, 9. 9 doesn't go into 12. 1 does, but 1 times 12 doesn't get us much place. So don't ever consider 1. Consider 4 and above, the perfect squares. 4, 9, 16, 25. Any of those numbers go into 12. Yeah, 4 goes into 12. How many times? 3. So I just chose to write 12 as 4 times 3. Pause the video and rewind that. Listen to that again if you're not catching on what I just asked you to do. I ask you to write 12 as the product of a perfect square. 4 times 3. Okay? Why did we choose a perfect square? Because I can take the square root of a perfect square. I can take the square root of 4 times the square root of 3. That gives me 12. Square root of 12, right? But the difference is I can take the square root of 4. The square root of 4 is 2. So this simplified is literally 2 times the square root of 3. That little x there is not x, it's the multiplication symbol. Remember I said there's only one case where we use the x for scientific notation. Well, our book used that for this one as well too. All right, so what did I do? I took what's underneath the radical symbol, 12, and I wrote it as the product of a perfect square and another number, 4 times 3. I chose a perfect square because I can take the square root of 4. The square root of 4 is 2. So this all turns into 2 root 3. You're like, Mr. C, I've been doing some simplifying, and that looks more complicated than what we started with. Okay, I understand where that comes from. I will just state, though, that I don't have the number 12 now. I have 2 smaller numbers, 2 and 3. And that's why we consider this a simplification process. Okay? Turns out that square root of 12 is equal to the 2 root 3. Neat trick. We need to do a bunch of practice, though, don't we? So I'm going to give you a square root of a non-perfect square. 75 is not on your list. Look through your list of perfect squares. What perfect square goes evenly into 75? Well, 4 doesn't, 9 doesn't, 16 doesn't. Notice I'm doing these in order, but 25 does. I can write 20, I'm checking my box 1, that's where I have my perfect squares written. I can write 75 as 25 times 3. Why did I do that? Because I can take the square root of 25. The square root of 25 is 5. So this just turns into 5 root 3. That is how you simplify non-perfect squares. Starting to make sense? Let's do another. Square root of 32, not a perfect square. Look at box 1. Does 4 go into 32? Yeah, 4 goes into 32, right? 4 times 8 is 32. What's the square root of 4? The square root of 4 is 2. Notice I'm kind of skipping some things because most people, this is how it's done. But wait a minute, 8 can also be written as 4 times 2. Now here's where you got to put your thinking cap on. If I took the square root of 4, I'd get 2. But I still have that other 2 on the outside. So what I would be left with is, well, another 2 times 2. So the square root of 4 is 2, and there's already a 2 there, which would be 2 times 2. So this would turn into 4 root 2. And here's the point what I want to make, is that don't just choose any perfect square. Choose the largest perfect square that goes into 32. Because check it out. Not only does 4 go into 32, but 16 goes into 32. If you choose the largest perfect square, you save yourself some time. The square root of 16 is 4, so I get 4 root 2. Notice what I'm doing. I'm taking the square root of 16, which is 4, and I pull it outside of the radical symbol. If you do it the long way, the middle column right there, Well, 4 times 8 is 32, and the square root of 4 is 2. So I pull a 2 out of the square root symbol. Then I'm left with an 8, and 8 can be written as another 4 times 2. Square root of 4 is 2, so I pull out another, because the square root of 4 is not 4, it's 2. So I pull another 2, which will give me 2 times 2, which is 4. Okay? We need to do another example, don't we? All right. Square root of 48, not a perfect square. What is the largest number that goes into 48? Well, hopefully from the previous slide, you aren't going to say 4, but many of you will say 4, because 4 times 12 is 48. So if you do this the long method, you'll still get to the right answer. This is called the long method because you didn't choose the biggest perfect square that goes into 48. But let's just say that you didn't realize that there's another number. What's the square root of 4? The square root of 4 is 2. But now look at 12. 12 can be written as 4 times 3. What's the square root of 4? Another 2. So you would be left with 2 times 2, which would be 4. So I'm left with 4 root 3. Once again, better method is to come up with the largest perfect square that goes into 48. In this case, 16. 16 times 3 is 48. But sometimes that just doesn't hit you really quickly, right? So I'm just going to say you can do it either method. One requires many more steps. One requires one step. Square root of 16 is 4, so we're left with 4 root 3. Does that make sense? All right. Let's do these two together. All right, look at your perfect square. What is the biggest perfect square that goes into 72? Okay, hopefully you realized it was 36. 36 times 2 is 72. What's the square root of 36? 6. So we get 6 root 2. You catching on? All right, 96, you start getting really big numbers, and a lot of times you're not going to realize the biggest perfect square that goes into it. So this is one of those cases probably for 96 that, you may not even realize 4 goes into 96. You may have to give this some thought. All right, well, let's see. Square root of 4 is 2, so we got 2 root 24. But wait a minute, 24 can be written as 4 times 6. Square root of 4 is 2. 2 times 2 is 4, so we get 4 root 6. If you had realized from the very start that there was a larger number that goes into 96, what's that number? Yeah, 16. So 16 times 6 is 96. But I'll just say this. Most of us can't do that kind of math in our head. Okay? All right. Generally, this is where I usually say let's put it on pause and write the answers. But how about we just do these together? Okay? I do want you to pause this, though, because I want you to make sure that you get to the answer before I get to it. All right. How about 120? What's the biggest number that goes in 120 that's on your list? Well, most of you probably don't see it, but most of you probably saw 4, right? So let's see. 4 times 30. Is there any other perfect square that goes into 120? And the answer is no. That's it right there. The square root of 4 is 2, so we get 2 root 30. Hopefully now you're becoming pros at this. All right, 108. Yeah, it seems like an awful lot of times we're using 4. Well, in this case, we're going to use 4 again. All right, so square root of 4 is 2, so we're done, right? 2. Root 27, unfortunately, right? 27 can be written as 9 times 3. The square root of 9 is 3, and 3 times 2 is 6, right? And that's generally because most of us don't understand that 36 times 3 is 108. That one's a hard one to see, okay? But it's not hard to see that 4 goes into 108. How about we do 2 more and we call it a day? All right, let's do 2 more. All right, what's the largest number that goes, or largest perfect square that goes into 80? Largest number that goes into 80. Well, most of us probably don't realize what that number is, but we certainly see that 4 goes into 80. Okay, so that would be what? 2 root 20? But 20 can be written, I left a step off here, I apologize. But 20 can be written as 4 times 5. Square root of 4 is 2. 2 times 2 is 4, so we get 4 root 5. How about 147? All right, so 147 is kind of a cheap shot. That one's really, really hard. Well, obviously it's odd, so it's got to be an odd number. So let's think of our odd perfect squares. 9 is a perfect square. Does 9 go into 147? Now, all right, what's the next perfect square that's odd? 25. 25 clearly doesn't go into it. No. What's the next? Not 36. 49. It turns out this is hard. So the ones that you're getting hard, I mean, I'm not saying I want you to use a By the way, if you do the calculator, your calculator will not give you these exact answers. It'll give you the decimal answer. All right, so what you can do is you can take your calculator, you can do 147 divided by 25, 147 divided by, 49, and you can at least see which number goes into it for the more challenging ones. I'm going to flip the page here and look at the homework tonight. We got a couple challenging ones. 18's pretty challenging. Yeah. Okay. So here we go. Okay, so square root of 49 is 7, so that's 7 root 3. You feeling more comfortable with this? All right, good. Okay, so that does it. There's your homework tonight, 2 through 28. Good luck with your homework. Go ahead and email me if you run into any problems. If you run into any problems. And good luck, and I'll see you guys, on Wednesday? Oh, yeah, Wednesday, remember we have the quiz.